Hello and welcome to this explainer. Today we are unpacking something that absolutely strikes fear into the hearts of so many computer science students. But honestly, it's absolutely critical for your success: subnetting and networks. Specifically, we're diving deep into the Cambridge AS and A-Level 9618 syllabus, though these concepts really span across codes like 0417, 0478, 0983, 0984, and 2210 as well. If you've been studying this subject for any length of time, you already know that subnetting isn't just some minor footnote at the back of the textbook. No, it is a foundational pillar. Think of your exam strategy kind of like being the captain of a cricket team, right? You've got to set your field, you have to carefully read the bowler, which in this case is the Cambridge examiner, and you have to know exactly how to safely and consistently score your runs, which are your marks. We see two types of students all the time. There's Alex, who overloads their answers with raw computer science facts, but provides zero actual analysis. And then there's Sam, who rushes through the paper, completely misses the command word requirements, and drops easy marks. Today, we are going to look right past those standard textbook definitions and literally open up the examiner's playbook so you don't make those same mistakes. By the end of this explainer, you won't just understand subnetting, you'll understand exactly how the people marking your papers actually think.
I really want you to listen to this quote, straight from a senior examiner. Mastering subnetting and networks is essential. This topic appears in every examination series. Let that sink in for a second. Every single series. You literally cannot avoid this topic, and you definitely cannot afford to just skim it and hope for the best. Every single exam series, without fail, is going to test your knowledge right here. We're setting the stakes incredibly high right from the jump because the examiners do. Today, we're looking behind the curtain to see exactly what they demand from a top-tier candidate. It's not about guessing, it's about knowing the rules of the game so you can play to win.
To get us to that top-tier level, here's our game plan for today. 1. Core principles. 2. The procedural framework. 3. Evaluative analytical thinking. And 4. Top examiner warnings. Let's get right into it.
Section 1. Core Principles. What Cambridge actually wants from you.
Okay, if there is one phrase you remember from this entire section, let it be this: analytical depth over superficial breadth. This is exactly where our hypothetical student, Alex, goes wrong. Alex tries to memorize 100 different little facts about networking, but rote memorization won't cut it here. You have to take the underlying principles and apply them to totally unfamiliar, messy networking contexts. Imagine they give you a scenario where you have to adapt a standard/24 network for a really complex multi-floor corporate office. It's not about knowing a bunch of shallow facts. It's about deeply, conceptually understanding the core mechanics so you can systematically analyze literally any network topology they throw at you on exam day. So, to achieve that depth, you have to satisfy 3 distinct cognitive domains, which are your assessment objective targets. First up is basic knowledge and understanding. You know, knowing your terms, your definitions, the real baseline stuff. But that's just the foundation. Next is the application to scenarios. You are rarely going to be asked a straightforward, generic question. Instead, you'll be given a highly specific business or technical scenario, and you'll be expected to mold your knowledge to fit it perfectly. Finally, deep analysis. This requires serious, evidence-based reasoning, where you systematically break down the network's needs. Understanding these 3 targets sets up the absolute necessity for a highly structured problem-solving approach. Before we continue and get into that actual framework, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. The procedural framework. This is all about earning your method marks.
This next strategy is arguably the single most important takeaway of this entire explainer. We call it the method mark strategy. Basically, this is the practice of securing your examination marks by explicitly demonstrating the correct, step-by-step procedural logic, even if your final binary calculation is completely flawed. Let's be totally honest here. Trying to do 8-bit binary math in your head while the exam clock is ticking down is a universally painful experience, right? It's stressful. But here's the secret. Examiners actually award marks for process. If you show your algorithmic thinking, your step-by-step decomposition, and keep your working completely clear, you are building your own safety net. You score points for the logic, for setting the field correctly, not just for getting that final binary string perfectly right.
So what is that exact process you need to follow when tackling these examination questions? You absolutely must follow this 5-step sequence. Step 1. Deconstruct the question. What are they actually asking? Look at the command words. Step 2. Extract relevant data. Physically pull the IP addresses, the required number of hosts, or the subnet requirements right out of the text. Step 3.
Select your analytical framework. Decide which subnetting formula or binary mapping you actually need for this specific problem. Step 4. Execute with clear notation. This is exactly where your method marks live. Write down the math, show the steps. And step 5. Present with correct terminology. Lock this exact sequence into your memory. It is your ultimate lifeline when you're sitting in that silent exam hall.
Now, to make sure you don't just completely freeze up when you turn the page and see a massive, intimidating subnetting scenario, I actually have a memory hack challenge for you. I want you to invent a mnemonic for those 5 steps. DESEP. That's deconstruct, extract, select, execute, present. Whether you come up with something like, does every student expect perfection, or maybe data extraction saves exam papers, it doesn't matter what it is. Just create something that anchors the specific strategy in your brain. Next time you sit down to do a past paper, write your mnemonic at the very top of the page before you even read the first question. It'll completely change your workflow.
Now, what's really crucial here is how we zero in on the exact data interpretation skills that are required once you've applied your framework. You are expected to smoothly extract information from raw binary representations. You've got to perform precise calculations, translating fluidly between binary, decimal, and sometimes even hexadecimal formats. But listen, it doesn't stop at the math. That final point is absolutely vital. You must draw evidence-based conclusions based on your calculations. Say you do all the math. Did that subnet calculation actually meet the company's requirement for 500 hosts? If it didn't, you have to explicitly state that conclusion based on the evidence of your calculation. You can't just leave the numbers hanging there. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 3. Evaluative Analytical Thinking. Let's look at the top scoring trade-offs.
A top candidate doesn't just find a mathematical solution and stop there. They actually evaluate its quality. Real-world networking is entirely about trade-offs, and Cambridge expects you to know this. For example, using a variable-length subnet mask might save valuable IP addresses, which is fantastic for address space efficiency, right? But on the flip side, it creates much more complex routing tables for the network devices to process. Cambridge wants to see that you can identify and evaluate these exact tensions in your exam answers. Don't just present a single undisputed solution. Show them you understand the costs and the benefits.
To really codify this mindset, let's look at the specific traits of top-scoring candidates. They don't just jump to the very first answer that pops into their head. Instead, they consider multiple solutions. They actively analyze those system trade-offs we literally just discussed. Crucially, they acknowledge technical limitations. If a subnetting architecture has a known flaw, or if it's going to heavily limit future scalability, they explicitly say so. And above all else, they justify their decisions with hard evidence pulled directly from the scenario provided. You can't just claim a specific network setup is the best. You have to prove it mathematically and logically before drawing your final conclusion.
Section 4. Top Examiner Warnings. This is where students lose the easy marks.
Okay, listen closely to the top 3 mistakes pulled straight from the principal examiner reports. This is where students like Sam, who rush, really drop the ball. First, candidates constantly forget to check overflow and edge cases in their calculations. Second, they are ignoring boundary conditions. For example, totally forgetting that the very first address in a subnet is always reserved for the network ID, and the very last address is always reserved for the broadcast address, which means absolutely neither of them can be assigned to a host. If you forget that, your usable host count is entirely wrong. And third, providing generic answers. If the exam specifically asks about a hospital's network, your answer needs to reflect the high-stakes, specialized, robust requirements of a hospital, not just some copy-pasted generic definition of a local area network. Context is everything.
I really want to issue a direct, high-stakes examiner alert for this next point. The reports explicitly state that candidates consistently confuse key terminology. The fix for this is incredibly simple, but it is highly effective. Always define your terms before using them in an extended response. If you're going to talk about a subnet mask or a gateway or a specific communication protocol, give a crisp one-sentence definition right out of the gate. It immediately signals to the examiner that you possess the correct baseline knowledge, and it beautifully anchors the rest of your analytical response.
We have covered a tremendous amount of ground today, right? From the core principle of analytical depth over superficial breadth, to securing your method marks with the DESEP strategy, to avoiding those critical traps that catch out so many students. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Now, take everything you learned today, sit down with a past paper, and go dominate it. Happy studying!